This preview is for evaluation only and cannot be used for public screening.
Countless number of stars, horizon to horizon, stretched our Milky Way. They are mere inklings of the boundless cosmos surrounding us. Our understanding of the universe has increased to a great extent. Our probes and satellites are our eyes, far deep in the realm of space. From the time when we considered the Earth to be the center of the cosmos, till today, when we have confirmed the existence of gravitational waves, mankind has traveled far in terms of unraveling the mysteries of the universe. We now know that the universe is not just immensely big, it's constantly expanding, growing further and further, stretching itself for the eternity of the times yet to come. In this endless universe, we can perceive and decipher as far as 46 billion light-years radius surrounding us. And though it may be a tiny fraction of the limitless expanse, it is big enough to seek the answers of the origin of everything, a part which we call the observable universe. Today, we are going to witness how this grandeur came into life. Let's begin from the time when the time itself did not exist. Once upon the Big Bang. Time. T equals to 0. The entire world as we know it did not exist. It will take another 13.7 billion years to reach where we are at present. There was no sound to carry and no light to see anything. They all will come later. The world at the birth of time is nothing but an infinitesimal point, a singularity. This is the hypothetical instant of the Big Bang. From this point, the expansion of the universe will happen. From a tiny, super dense, super hot speck to the enormous cosmos of our era. We are yet unknown to the reason behind the expansion, but somehow it came in motion. Time started ticking. And in the next fractions of the first second, this speck turned as big as the size of a grain of sand. No matter how minuscule this grain looks, our universe right now is unfathomably hot for our known fundamental forces of nature to exist. The expansion continued. Another few fractions of the first second have passed. Our universe
This
now
preview is
equal
for
to the size
evaluation
of a football
only
ground.
and cannot be used for public
But
screening.
even now, the universe is nothing like the universe of our lifetime. There is no galaxy, no stars, and not even the building blocks of everything, atoms. Instead, everywhere, it's just energy, the purest form of energy. In the first fractions of a second, the universe generated all the energy it'll ever need. This energy will turn its form in the due course of time, and with more expansion, will give birth to matter. For now, the atmosphere is filled with an energy field, a kind of subatomic particles called gluons. Gluons created the pairs of quarks and antiquarks. They were the initial building blocks of matter and antimatter. But the moment they took birth, they also annihilated each other, released more and more radiation. This stage continued for a very long time. Might the quarks and antiquarks have taken birth in balance, we would have never been born. They would have kept annihilating each other forever. But fortunately for us, there was an imbalance. For every 1,000 antiquarks, there was 1,001 quarks. With the further expansion of the universe, the atmosphere kept cooling down. Soon, the energy field became inept of generating new quarks or antiquarks. Once the annihilation stopped, we got the world full of quarks. Our world is the outcome of an imbalance of nature. The universe is not just energy anymore. It is an orange, opaque, searing plasma of protons and electrons. Still extremely hot to produce any stable matter. However, it is expanding and cooling down with every passing second. From the beginning till here, the universe is only a few moments old. The universe is almost 400,000 years old and about the size of the Milky Way. Somewhere in this time, the scorching hot plasma cooled down to the temperature of 3,000 degrees Kelvin, where particles became stable and bonded with electrons. The very first hydrogen atoms have formed. The plasma slipped down into gas. At that same instant, the previously trapped infrared light also got free. Suddenly, there was a burst of light. The universe got filled with immense brightness. Light was free to travel across the width of the cosmos. The universe turned from opaque to transparent. For the next 200 million years, the gaseous universe kept expanding, cooling down, getting darker. It's now stretched to the billions of light years across.
This preview is for evaluation only and cannot be used for public screening.
The overall temperature drops so low, space is now colder than liquid nitrogen. The swirling clouds of hydrogen atoms are everywhere. Strangely, they are not evenly distributed. There are cracks in the fabric of space. There are forces of nature at work now. Gravity started pulling the gas closer. They are forming denser regions of clouds, becoming smaller and hotter. The atoms began fusing and releasing energy, and the gas clouds started to burn brightly. These are the first stars of our universe. All around space, millions of the first stars lit up together. In the most spectacular fashion, our universe was once again filled with light. These young stars are made up of hydrogen and helium. Though they are nothing like our sun, they are very unstable. These are the first factories of our universe. Through a nuclear reaction, they are forcing atoms to fuse together and create heavier elements like carbon, magnesium, or the heaviest, iron. Essentials for the formation of solar systems and planets. But the vital elements of organic life require an even more massive process. Soon, the stars will run out of fuel and collapse into themselves. Releasing incredible amounts of energy, which will fuse the atoms even further and create heavier elements than iron, like zinc, gold, or platinum. These starbursts are supernovas. The debris of these stars accumulates together and gave birth to the much complicated systems of the universe, like galaxies, solar systems, and planets. And eventually, they brought the building blocks of life into existence.
This preview is for evaluation only and cannot be used for public screening.
From the first intense second of the birth of time till now, 1 billion years have passed. The universe, as we know it, starts to take shape. Soon, from one of the dust clouds, our Milky Way will take shape. Our solar system, with all of its glory, will come to life. It'll take another 13 billion years of evolution before any kind of life will take its first breath. However, the pieces of the puzzle are set in the right places. Once freed, infrared light stretched further. It's not bright anymore. It got fainter. It turned into cosmic microwave background. Though it still is the relic of the early stage of the universe. The universe is still young. And another 4.5 billion years after the birth of Earth, our eyes in space would observe the expanse of this vast universe across space and time. And someday in the future, we'll be able to connect all the dots and would be able to see the whole mystery unravel.